Let's take a look at the random number method we used in the game program, the guessing game program we just made. It seems to have an odd bias. I ran the program a bunch of times and got back a pretty interesting result. And the interesting result that I got back was that I always got to it in 8 steps, if I typed in the right thing, that is, which led me to think that that seemed kind of strange, because you would think that on average I wouldn't. So what I did is modified the program to just output random numbers and grabbed a whole bunch of them, and there's an interesting pattern here. The last digit, 9, D5, 5, 5, 9, 5, 9, D, 5, 1, 5, 9, 1, 9, D, 5. They're all off by 4, and this is actually something that makes a lot of sense due to the micro-coded architecture. We take 4 clocks to execute any instruction. So anytime we go to the same clock that we're using, that clock would be some multiple of 4 times the original number, or some addition, I guess. I'm not quite sure how you'd put it. But I think we can solve the random number problem here pretty simply by using 10 bits and shifting right by 2 bits to get the 8 bits, because the other bits seem pretty random. Maybe not so much in this case because the program is running and continually polling, but it does seem like that would be a good solution to the problem. You can see all the results coming out here at that kind of a rate. So interesting what's going on. And every time I start it seems to want to run again. There we go, it stopped. And 1, 5, 1 plus 4 is 5, 5 plus 4 is 9. All of these, again, increments of our 4 clocks. So let's try playing with the random number generator and see if we can fix that problem. First thing we want to do is to not have it continually loop dumping out numbers, because it's just too fast and too many numbers. Let's have it loop back to the wait for key hit and do that. That should be a good first step here. And if that works right, we ought to be able to just do a single number per line. But we should see the same result because we haven't fixed the problem. The problem is still the same. So we'll go ahead. Get the memory initialization file, as usual. And start the compilation. Yeah, it seemed awfully strange that I would continually always get to it in 8 steps. You would think that on average there'd be something less than that I would guess on one of those steps right, but I think it just gets in lock sync with not being right ever in randomness. So it's not truly a random number generator, although the upper bits probably are pretty good, but the bottom 2 bits being in sync with the CPU are never going to be good. So let's see what that did. Hopefully that'll let me do a number at a time. So yeah, it does 9, 5, D, 9, 1, 9, 5, 9. So it looks like it's in that last digit is always going to be the same. I think it's only those 2 bits though, because E5, 8, B, 8, 8, C, B and C are a little bit off from each other. So let's do the same thing we did here, which is load that number, but let's shift it right by 1, R8, and let's repeat that again, and we'll leave the ending there. So hopefully that'll shift the number over and still truncate it at 256, 0 to 255, so 8 bits. Go back and build that again. I'll probably want to compile it first, otherwise, or assemble it first, because it's not going to be very good. Hopefully this will be a better random number generator, and with the human pressing the button between the runs, it should be truly random. Processing, update memory, yes. Tell it to go and compile the FPGA, which includes the bits we need that we just made. And it's done. And let's see what we get now. F5, 4, 7, 5, 1, 2. Yeah, so we're no longer having that same problem, and hopefully that'll make the other test pass quicker. We'll use this back on there, but I've uploaded this program for random numbers, and as long as there's a human in the loop randomly pressing the next number, the value should be truly random. E9, yeah, so we've got all the bits are changing there, it looks like 79 and 09, so the least significant bit does change here, 0, 2, 1, 2. Yeah, we're definitely stepping through the right kind of values here. I like to grab a bunch of this data and run it through a program like Excel or OpenOffice Calculator and see what I get for the results and see how truly random they are. Probably throw them in a scatter plot and see what comes up. But for now, I think this will do. We'll give it a shot and see how it works with the original game. The reason I concluded that always getting an 8 was wrong is that, yeah, when you start, you've got a 1 in 256 chance, which is about 0.39%. But as you go on with time, that chance increases. By the time you get up to 5, you got a 1 in 8 chance. 6 guesses is 1 in 4. 7 guesses is 1 in 2. So it ought to have, at sometimes at least, done maybe a lot of 8s, but some 7s, less 6s, less 5s. And that's what I saw. I saw completely all 8s. So that was a clue that there was something wrong with the random number generator method. So here the code is put back into the hex guess game. Hopefully this will work. Unfortunately, this does take a little while to compile because when you change to a different program folder for those memory initializations for the program and data initialization, it has to run through the whole compile cycle again for about a minute and a half, and we'll skip past that to save us all. Well, I did it again. I forgot to recompile the random number addition, and it looks like it worked. So I got a 7 there, which indicates to me I'm out of sync, but let's take a look. 80's too high, 40, 60, 70, 68, 6C, 6A, 69. So that was 8. That's 80. Let's try again. Too low, C0, too low, E0, too low, F0, too low, F8, too high, F4. I got it in 6. Okay, it looks like the random number generator appears to be working properly. We were able to get numbers better than 8, which the 8 indicated we were synchronized up with our clock and the random number generator. Now we shouldn't be. We're no longer have those powers of 4, which is our processor microcode execution of 4 clocks for the 4 stages of our pipeline, or not really pipeline, but anyway, I think that solved that problem, and other than forgetting to recompile, I keep making that mistake, looks like it's working great. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.